நீங்க சூப்பர் எல்லாரும் மோஸ்ட் தலைவா சார் You ready? Action. Sir, one more. Ready? Fine. Ready? எத்தனை பேருக்கா பிரிச்சு கொடுத்தது உள்ள வந்து சொல்லுங்க Okay. Ready? Last one. Ready?
The tech legend who's been right about everything from LinkedIn to AI just got voice pilled. And this is what he posted. If you use products like Whisper or ChatGPT Voice, you know what I mean. Voice is simply faster, more natural, and more flexible than typing. He said he's voice pilled, and I can see why. WhisperFlow delivers what Reed calls the future of AI interaction. Here's how it works.
Instead of typing, just talk. WhisperFlow cleans it up instantly.
Reed explains that voice is iterative by default. You stumble, you rephrase, you interrupt yourself. WhisperFlow handles all of that and turns it into perfect prompts wherever you're working.
Reed predicts we'll all be prompting AI more. And voice lets you add way more nuance and detail. Better prompts, better results. That's why he calls Flow's voice dictation a major step forward in human-computer interaction. If AI visionaries are raving about it, you should probably give it a try too. It's free. Get voice pilled with WhisperFlow today.
The model can take text, images, audio, or even video as input. Next is the encoders for each modality. That means a text encoder converts words into vectors, and an image encoder converts pixels into vectors, and then an audio encoder converts sound waves into vectors. Next is the shared embedding space, where all these different inputs are translated into a common AI language, which is a vector space where similar meanings are close together. For example, the word car and the picture of a car are mapped close together. Next is the Fusion Plus reasoning layer, where a multi-modal transformer uses cross-attention to connect relationship across text, images, and audio. For example, it links the word red to the red region of the car image. Next is the output generation. So finally, the model generates a response, which could be text, a caption, an image like DALL-E, or even sound. Alright, I hope this is clear now. So now let's look at some real-world examples that make it easier to understand. So first we have ChatGPT with Vision. So if you upload an image to ChatGPT and ask what's in this picture, then it can describe the objects, text, or even analyze data like a chart. So that's multimodal AI. It's using both image understanding and text generation together. The next example is Google Lens. So when you point your camera at something, Google Lens can recognize the object, read the text in the image, and translate into another language. Again, it's a vision plus language plus translation all in one model. The next example could be a self-driving cars. So autonomous cars like Tesla's uses multimodal AI because they have to see the road through cameras, read traffic signals, hear alerts, and also process maps and text instructions. So they combine all these modes to make driving decisions. Next is the healthcare AI. So doctors now use AI that can look at medical images like X-rays and also read patient reports, combining the information to help diagnose diseases more accurately. But why is multimodal AI a game changer? Multimodal AI is powerful because it's closer to human intelligence. We don't rely on one sense, we combine many. And it makes AI more flexible because one model can handle text, images, audio, and more. It can solve more complex problems like explaining what's happening in a video or understanding a full conversation with context. Alright, now for those of you who want a bit more technical depth, here's a quick peek behind the scene. So as I discussed earlier, a multimodal AI uses transformer-based models, the same type of models behind GPT. So the text, images, and audio are all converted into a common representations, like a shared language of numbers called embeddings. For example, a picture of a dog and the word dog are both mapped into a similar space. So the AI knows they mean the same thing. Then the model can reason across all modalities together and generate an output. A great example is Clip from OpenAI, which connects images and text. Another is Google Gemini, designed from the ground up as a truly multimodal model. So what is the biggest challenge? So the different types of data have different formats and complexity. Combining them efficiently without losing meaning is still an ongoing research area. So it's not just a magic, so it's smart design that lets the AI translate everything into one common understanding. Let's now look at some of the most important multimodal models, how they work, and where they are used. So here are the key multimodal models. So first on the list we have CLIP, which is CLIP, which stands for Contrastive Language Image Pre-training from OpenAI. So let's see how it works. So it has two encoders, a text encoder and an image encoder. So both encoders map inputs into the same embedding space. So during training, it learns this caption matches this image and this caption does not match that image. So it uses contrastive learning. It pushes correct pairs closer and incorrect pairs further apart. So here is the working diagram. So it takes the input, be it image or text, and then it encodes. So an image is a vision encoder and for text is a text encoder. Then it is shared to an embedding space. And finally, it generates the output. So let's have a look at the use cases. So it is used in DALL-E and Stable Diffusion to align text prompts with images. Next, it is used in zero-shot classification, where you give it a photo of a dog versus a photo of a cat, and it recognizes which one matches the image without retraining. And then it is used in search, where it finds images similar to this caption. Next, moving on to second model, which is BLIP2. It stands for Bootstrapping Language Image Pre-training. So let us see how it works. So first, it connects a frozen vision encoder, for example, a CLIP or VIT, with a frozen large language model, which is LLM. A query transformer acts as a bridge, where it converts visual features into a language-friendly representation. So here is the working diagram. The AI first looks at the image and turns it into features like objects, color, and shapes. Then A small bridge model called QFormer takes those visual features and converts them into a format the language model can understand. Next, the large language model then reasons about the image features just like it reasons about text. And finally, it generates a text answer or a caption describing the image. So, Vision Encoder sees and QFormer translates and the LLM explains. So, let's have a look at the use cases. So, first, it is used in visual question answering. For example, what's in this picture? Next, in the image captioning, where it can give it like a man riding a horse on a beach. Next, in a chatbots with vision. For example, where you upload an image and ask questions. Okay, the next model on our list is Flamingo from DeepMind. So let's have a look at its working. So here's how it works. So first, it's a few short multimodal model. It doesn't need huge fine-tuning for a new task. And then it uses gated cross-attention layers to integrate image plus text inside a frozen LLM. And it can reason across multiple images and a long text sequence. So it looks at the image, reads your question, connects both through cross-attention and then explains it. So let's have a look at the use cases. So it is used in multimodal chatbots like look at these 5 images and now answer this question. Next, it is used in educational AI where it reads diagrams plus answer questions. Next, in document understanding where it reads text plus images in a PDF. And the next multimodal on a list is PaLM-E from Google. So here's how it works. So as you can see, this is the working diagram. So first, the AI gets both visual input like a photo or a live camera feed and the text instructions like pick up the red apple on the table. Next, the vision transformer understands what's in the image like objects, colors and position, and the PaLM language model understands the instruction and reasons about what needs to be done. So it's combining both. The AI creates a step-by-step action plan for the robot like move forward, grab the red apple and place it in the basket.
We're excited to introduce conditional remote configs on ByteBrew. Using ByteBrew conditions, you can distribute live remote configs to different segments of players based on attributes like build version, country, custom data, and more, enabling you to create curated in-game experiences for segments of players without having to constantly update the app stores. So, what are you waiting for? Sign up now and start using ByteBrew in your game free today.
Gemini has a single model handling all modalities and it uses joint training with cross attention. So this is the working diagram. So let me explain this. The AI takes in all types of inputs at once, such as written text, pictures, sound, and even video. Then, instead of using separate models for each type, it uses one powerful transformer model that can understand and combine all these inputs together. And from that combined understanding, it can give any kind of output, a text answer, a generated image, or even an audio response. So basically, it understands everything together and responds in any form you need. So let us have a look at its use cases. It is used in complex queries, such as summarize this video and create a chart. It is used in advanced digital assistants and also in future AR, VR multimodal applications. The next model is GPT-4o from OpenAI. It's an optimized multimodal model. It accepts text, images, audio in real time. And it uses fused embeddings and parallel processing for speed. And it works as a true interactive assistant. So here are its use cases. It is used in conversational AI with vision plus audio and in real-time assistance where you upload an image and get explanation instantly, and also in accessibility tools. For example, describe surroundings for visually impaired users. So these models represent different approaches to multimodality. Some align separate encoders like CLIP, some bridge vision plus LLMs like BLIP2, and some are natively multimodal like Gemini and GPT-4o. So now let us see how our multimodal models trained. So training multimodal models is much more complex than training single model models. So first is the dataset alignment. So you need paired datasets such as images plus captions, videos plus transcripts, and audio plus text. So this challenge is the text and images don't always align perfectly. Next is the contrastive learning. So train the model to pull matching pairs closer and push non-matching pairs apart. For example, image of a cat plus caption, a cat, is a matching pair, whereas image of a cat plus caption as a dog is not a matching pair. Next is the masked modeling. Mask parts of the input such as image patches, text tokens, as model predicts missing information.